Alright, so I will be gone today because I have some professional development, so I'm going to make a few videos. I'm sorry if it's a little loud in the background here. I am currently sitting in a Starbucks because I'm on dorm duty this weekend. So I'd much rather be in class with you guys, but I got to be gone for this curriculum mapping, so I'm making some videos for you. So I'm going to have about, I think, 2 videos here, mainly just example problems of the stuff for today, and then at the end I'll have about 5 questions of practice for you. That is all you're gonna get, that you guys are going to have to do in class today. You guys will have a homework assignment, we will actually work on some more practice in class when I get back on Thursday. So today we're going to work on 9.4H. This is called solving trig equations. Okay, solving trig equations. So before we get into any solving trig equations, I'm going to go ahead and set up over here on the side our special right triangles, along with the way that we can help remember sine, cosine, and tangent. So we'll go ahead and draw that right now. Here's our 30, 60, 90 triangle. Okay, we have 2, 1, 3. This is 60 degrees. This is 30 degrees. Okay, we've got our 45, 45, 90 right here. 45. 1, 1 over 2. I'm going to put a couple notes here. Pi over 3 is 60 degrees. Pi over 6 is 30 degrees. And pi over 4 is 45 degrees. And along with this, I'm also going to draw the circle with a radius of 1 to help us remember over here. 1, 0. Here we've got 0, 1. Negative 1, 0, and 0, negative 1, and please remember cosine goes with x, and sine goes with y. So whatever the x value is at any of these points, that is the cosine value, and whatever the y value is, that is the sine value. Okay, so let's jump right into it. So first problem here, example 1, we will have 2 times sine of theta plus the square root of 3 equals 0. And we're going to take this equation right here. I'm sorry if it is loud in the background. I have some neighbors here who are being pretty loud at the table next to me. But, so we're going to take this equation and we're going to solve for all values of theta. Okay? So just like any equation, what we're trying to do here is we're trying to figure out what values can I plug in for theta that are going to make this entire statement true. Okay? Now, every single one of these problems is going to have 2 parts to it. It's going to have an algebraic part, and it's going to have a trigonometric part. The first part, the algebraic part, is getting the trig ratio by itself. Okay? So in order to do that, this is a real easy one. We are going to subtract the square root of 3, and then we're going to divide by this 2 right here, so we end up with this, okay? So this is the trig part, or I'm sorry, this is the algebraic part. Algebra, we have now finished the algebra part. We got the trigonometric part by itself. Next up, we're going to switch gears and we're going to start talking about trigonometry. So from here, what we need to figure out is what values of theta are going to create a sine ratio of negative root 3 over 2, okay? Now, what I like to do on this is draw myself a little picture to start out. First of all, sine goes with y. If sine is negative, the 2 places on a coordinate plane where y are negative are in the 3rd quadrant and the 4th quadrant. So what we know right now is that we are getting angles in the 3rd quadrant and the 4th quadrant for our answers here. Okay? What we next need to figure out is what's the reference angle that creates a sine value of root 3 over 2. Well, if we come over here and look at our triangles, that's going to come from this 30, 60, 90 triangle right here. The angle in this triangle that has a sine value of root 3 over 2 is 60 degrees. The opposite side is root 3, and the hypotenuse is 2. So if we're making a little note here, the reference angle with this sine value is 60 degrees or pi over 3. But what you have to remember here is we are working in the 3rd quadrant and the 4th quadrant. So the angle, we're setting up our theta values here, the angle in the 3rd quadrant with a sine value of root 3 over 2, the pi over 3 in the 3rd quadrant is 4 pi over 3. Okay, and I'm actually going to stack these on top of each other for now, and I'll show you why in just a second. Then in the 4th quadrant, the angle is 5 pi over 3. Okay. Now, here's where this is a little bit new and a little bit different from what maybe you think right off the bat. Between 0 and 2 pi, these are the only two angles that are going to make this a true statement. Okay, but notice that the directions here say solve for all values of theta. So what I'm actually going to do here is on top of this 4 pi over 3, I'm going to add on a plus 2 pi n, where n is any integer. Okay. Now here's what I mean by that. Let's say, for example, I plugged in 5 for n right here. What that means is I would go to 4 pi over 3, and if n was 5, that means I would add 10 pi to 4 pi over 3, meaning I would just start right here, and I would take one trip around the circle is 2 pi, so if I plug in a 5 right here, that just means I would take 1, 2, 3, 4, 5 trips around the circle, and I would end up in the exact same spot. Okay? I'm also going to go ahead and do the same thing here on 5 pi over 3. I'm going to add the plus 2 pi n, because if I added 2 pi n, any number right here for n, if I start here and plug in any number that's not decimal, that's going to end up in the exact same spot. So I'm solving for all possible values of theta. This would be my answer. This is the trigonometry part. I'll check for that because we are now done with that part as well. Okay. Pretty much all of our notes for today are just going to be some examples of me solving some equations that will get progressively a little bit more difficult as we go. Okay? So, example 2. We'll have the same directions here, and our equation this time is tangent of theta equals tangent cubed of theta. Okay, so we'll note here, tangent cubed of theta is equal to tangent of theta cubed. Okay, so it's just tangent being multiplied by itself 3 times. Okay, if you look at this equation, what you'll notice, we'll start with the algebra part here, is that this is a polynomial equation because we have an exponent of 3. Just like the rest of the year, anytime we solve one of these, we always want to get one side equal to 0. So I'm going to start out by subtracting tangent of theta from both sides of the equation. From here, what I notice is there's a GCF here. Both of these terms have a tangent of theta. So I'm going to start by taking out a tangent of theta. If I had 3 tangents and I took one out, now I have a tangent squared of theta. And if I take all of this out, I need a 1 as a placeholder. Okay? From here, what you'll see is I now have a product, one thing times another thing, that is equal to 0. So I'm going to go ahead and use the 0 product property here and say tangent of theta equals 0, and tangent squared of theta minus 1 equals 0. Okay, this is as far as I can go in terms of the algebra on this. There's a couple other things I can do on this part though. I can add 1, and then I can take the square root of both sides. Now remember, when you take the square root of both sides, you must have a plus or minus in front of your answer. So the squared cancels out, and right here the square root of 1 is 1. We'll put the plus or minus because it happened in the equation. At this point, the algebra part of this problem is done. I have solved for the trig ratio. Now I need to start thinking about where do these things happen on the circle. Okay? So let's start out, we'll split this up. Let's start out with tangent of theta equals 0, and we'll go from there. So for tangent of theta equals 0, this is not going to come from one of these triangles because you do not see a 0 anywhere here. Okay? But remember, tangent is sine over cosine. Okay? So if tangent is equal to 0, then what that means is sine of theta is equal to 0. Okay? So there's 2 spots on the circle where sine is equal to 0. When y equals 0, then sine equals 0. Okay, and if we're thinking about this, that's going to be on the right side of the circle and the left side of the circle. Both of those have a y value of 0. So if we were thinking about this, this is the angle 0, and this is the angle pi. Okay, and if you think about us going around the circle here, this is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. What this simplifies down to is a pattern of pi times n. pi times n is going to give me to the right side of the circle or the left side of the circle every time, meaning that's always going to give me a sine value of 0. Okay, so I have half the equation solved now. Now let's move over to this statement. So, tangent of theta is equal to positive or negative 1. First of all, let's figure out what quadrants we are working with. Okay, tangent is positive in the first and the third, but it's negative in the second and the fourth. So in this case, we are actually working with all 4 quadrants on the circle. So next up, let's move over here and let's figure out what angle does this come from. Okay, I am not going to get a tangent value of 1 from this triangle, but I will when I look at the 45-degree angle. Opposite divided by adjacent, they're the same, so when I divide them, I get a tangent value of 1. So if I start thinking about what this reference angle is pi over 4. So what that means is I need this to be pi over 4, pi over 4, pi over 4, and pi over 4. And if I'm going around and thinking about that, that gives me pi over 4 in the first quadrant, 3 pi over 4 in the second quadrant, 5 pi over 4 in the fourth quadrant, or third quadrant, and 7 pi over 4 in the fourth quadrant. Now there is a little pattern here for this particular answer. What you'll notice is if I start at pi over 4, each one of these are pi over 2 apart from each other. Pi over 4 plus pi over 2 is this, 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 plus pi over 2 is this. So, if I take pi over 4 and I add pi divided by 2 times any number in the world that is not a decimal, that is going to get me to one of these 4 spots on the circle, because they are all pi over 2 apart from each other. Okay? So the second part of my answer for this problem is pi over 4 plus pi over 2n. Combined with the first part, that gives me the full solution to this trigonometric equation. Okay? I'll have one more video that has about 2 or 3 other examples in it, and then at the end of that video I will have some practice for you guys.